Hello and welcome back, and in this video we'll take a look at execution time of an algorithm. Without a further ado, let's get started. So the execution time of an algorithm can be computed using an empirical relation, and this is the relation. TE stands for execution time, which is equals to n times A plus n times B plus n times C plus n times T. So A here represents the assignment operation or the time taken for the assignment operation, and B is the time taken for the comparison operation, and C is the time taken for the increment operation, whereas D stands for the time taken for print operation, and N here represents the number of occurrence of these operations in the program. So to illustrate this, let's take a look at an example. We'll start with the sequential algorithm. So to understand the execution time, let's consider a simple sequential program and printing text called hello world, right? So this is written in C. It has the standard input output header file, and then void main file, and then we have the parenthesis underneath. In between that we have printf hello world, and this gives us the output hello world as mentioned here. And this is a sequential program, which means that the execution happens sequentially. First it includes the header file, the standard input output files, and then it looks into the void main. If we don't get void main, if we only keep the main, it will require the return function to exit the program. But since I've given void main, and it will execute once the the function gets terminated, right? So this is the typical simple sequential program, and I've just rewritten that with the tabular column. Remember, in the empirical relation we have got the assignment operation, the comparison, the increment operation, and print or display operation. And let's compare this with the code. And this code has no assignment operation. We have not assigned any variable here, and we also do not have comparison and increment operations. So A, B, C is 0, whereas we have a function called print, which comes under the print or display operation, and D, which is the you can see we have except from the code, which is the printf, and then the occurrence of that is only once in this program, right? So the execution time will be 0 times A plus 0 times B plus 0 times C plus 1 times D, and it is equal to 1 into D, and we can ignore this constant term D, and then there is approximately equal to 1, which is also a constant. So this program takes a constant time, which is 1. Let's take a look at the another example in which we can look into the assignment operation or something like that. So this is example number 2. In this program, we'll try to add two numbers. We have got three variables A, B, C, and we have initialized value for these two variables. Like this are initialized data where A is given a 2 and B is given a 3 and C is uninitialized. And then in the next line C equals to A plus B, so which means that C the value of the C depends on A and B, the operand A and B, plus this is an operation, addition operation, right, based on these values, and we get the value of C. And then we have a print f statement, so to print the value, the resulting value of C. And this is also a sequential program, which means that this gets executed in a sequential manner, right? And we have got int main because the return value, the value of C is integer, right? So that's the code. And then the output of this code you can visualize here, like the output is the value of C equals to 5, so which is 2 plus 3 is 5, right? Let's take a look at this with the comparison with the table. This is the code, and this is a comparison of the table, and we have got the assignment operation, comparison, increment, and print or display. Let's take a look at its occurrences, the notation A, B, C, D. And assignment operation, like you can see, I've assigned A to 2, B to 3, and C is also an assignment operation because C equals A and B, right? So A plus B, right? So which means in total we have got 3 assignments like A, B and C. So A equals to 2, B equals to 3 and C equals to A plus B, 3 assignments in this particular core. So the occurrences is 1 plus 1 plus 1, which is like 1 times A. I mean, here do not confuse this notation A with this variable A, right? And also the B and this variable. This is to indicate the assignment, comparison and increment. But here I've given A, B and C. Probably you can take X, Y and Z. So to avoid confusion, right? Right. So we have 3 occurrences of these assignments and we don't have any comparison here. Like we don't have any comparison operation and increment operations also. Right. So these things probably we can take a look at that in the iterative algorithms when which we use loops, for loops and nested loops and so on. But as of now in an sequential program, we don't have comparison and increment. And then we have got the printf statement which will print the value of C, right? So totally we have got 3 assignment operations and 1 display or the print operation. In total it is 3 times A, which is 3 times A, and 0 times B plus 0 times C plus 1 times D. So that will comes under 3A plus 1D. And you can ignore these constants like in the previous example. A and D can be ignored and that will be approximately equals to 3 plus 1 is equals to 4 constant unit, right? So this is typically the sequential program. Let's take a look at the iterative algorithms. So iterative algorithm has a scope for the comparison as well as the increment operations. Let's take a look at one example. So this is an example for finding out the square of n numbers, and we use for loop. So up to this is sequential, and then we have a for loop, so which means that this loop will terminate when I equals to n, right? So this is typically a for loop. Let's explain the code. Right, so let's take a look at the for loop alone. Like the initial data, we have got 3 variables like I, n and a, and all these things are uninitialized at this point. Whereas in the for loop, we have initialized the value of I in the initial stage, which is the start, which is 1, and it gets going, the loop gets going till I reaches n. Right, and an increment of 1. So I plus plus stands for it gets incremented by 1 unit, right? And then what does that does is that like we have an assignment operator here, so which is A equals to I into I. So which means that in the first iteration when I equals to 1, it is 1 into 1, which is 1. So the value of A will become 1. In the next iteration, it will become 2, which is 2 into 2 is 4, and so on till the last value or the final value. Here we have not defined the final value, we have just given this as n. But if you have the n equals to 10 or n equals to 20 and so on, that much time this particular loop gets activated. And then we have got the print statement to print the value of A, right? So this is a typical example. Let's compare this with our standard table and assignment operations. Here we have got I equals to 1. So this is one assignment, and A equals to I into I is also an assignment, but this is in the loop, right? If you take a look at that, so here the assignment happens at 1. Assignment I equals to 1 happens 1, and A equals to I into I, it doesn't, we have only written it one time, but it will execute it for n times. For I ranges from 1 to n, it executes it for n time. So that is why the occurrence of A equals to I into I is n times. So this is typically assignment operation happens at 1 plus n times y. And then the comparison operation, here we have got the comparison operation I less than equals to n, and this happens n times. So this loop is for n times, so this happens at n times, and increments also, it ranges from 1 to n, so it gets n times. And then print or display option, right? So here we have given only one print, but then it is given within the loop, so which means that it gets print n times. So initially the value of a equals to 1 into 1 is 1, and the next iteration it will becomes 2 into 2 is 4, and so on, right? So till the value of n, till the n iterations, it gets printed, right? So each values of a, it's computed and gets printed. So and hence the printf will be activated till I equals to n, right? So that is why we have got n occurrences, right? So we'll use that to find out the total elapsed time or execution time of this algorithm using our empirical relation. Here instead of n into a, we have got 1 plus n into a, and n into b, and n into c, plus n into d. So we have put that in the formula. And then 1 into a plus 1, n into a, so we can separate them, and then that will give us like 1 into a, or just a, plus n times, which means that n into a plus n into b plus n into c plus n into d. We take the n common, so that is this term. Since this is a very standout constant, we can ignore that. And then in the final computation, we can ignore all these constant terms, and that will leave us with the the constant n unit. So the operating time or the execution time of this algorithm, the for loop, this particular for loop is n. Let's verify this with an example by giving or assigning the value of n, right? So we'll assign some values to n. Let's take a look at whether we get the n units or something like that, right? Say for example, if you incorporate or if you assign n equals to 2, then the execution time of the algorithm, when you assign n equals to 2, then the execution time of the algorithm should be 2 units. If you give it 5, it should be 5 units. If you give it 100, n equals 100, the execution time of this should be 100 time units, right? So let's take a look at that. We'll assign n equals to 5. In this case, we are assigning n is equal to 5. So when I assign n equals to 5 and run this particular program, you can see it runs for 5 times. Like the output is visualized here, and you can see it is executed for 5 times. So initially the value of a at 1 equals to 1 into 1 is 1. And then the second iteration, it becomes 2 into 2 is 4. And in the third iteration, it becomes 3 into 3 is 9. And fourth iteration, it becomes 4 into 4 is 16. And in the fifth iteration, it checks whether I equals to n, then it terminates. And then, it just executes and then it terminates. And then at the next step, it becomes I equals to 6, and 6 is not less than 5. And it gets terminates, as simple as that, right? So this gets terminated here, and it will exit the program. So that is how it is 5. So I've given n equals to 5 and it executed for 5. And if you able to compute time, you can see the time taken to compute each line of this output, that will be 5 times the single output, right? So that is the 5 time units, right? Something like that, right? Let's also compute this with table. Here the assignment operations are many. Actually, we have included n equals to 5, that is also an assignment, and I equals to 1, that's also an assignment, and a equals to I into I, it's n times. It happens n times, it's actually 5 times, right? So that is why it is 1 time here, the assignment, and here it is 1 time, and then this happens 5 times because n equals to 5, and the total of 7. And B is the comparison operation, which happens 5 times, and C is the increment operation that happens 5 times. The loop is for 5 times, and then you can see that. And D, print, you can see from this output, it happens 5 times. The printing of the output is 5 times, and hence the 5 here. And we will usually incorporate this in our formula, empirical formula, which is 7 times A plus 5 times B plus 5 times C plus 5 times D. And we can even equal to we can do this 2 times A plus 5 times A, so that you can take the 5 times outside. So 5 into A plus B plus C plus D, and then you can ignore 2A, and then finally you can ignore all these constants, and that will lead us to 5 units. So this is typical example, like, so n equals to 5, it's 5, and you can even generalize this case. For iteration 1, which is 1, n equals to 1, we got the time to be 1, and n equals to 2, it's 2, and some constant k ranging between 1 to n, and then that will be 5 times, and in general n minus 2 is n minus 2 units, n minus 1 is n minus units, and n is n units. So in general, the execution time of this for loop algorithm is n for n iterations, and something like that, right? So this is typically an example of the iterative algorithm. In the next video, we'll take a look at the nested for loop, and then we'll build up this idea to explore the recursive algorithm, and that will be the final part of this action time of this algorithm. I hope you really enjoyed this video. Have a great day. Bye bye.